Hello everyone. In this video, Kepler's law of planetary motion from physics. Kepler. Says is the law is law. There are three laws only written. What are they? Laws of orbit, laws of areas, laws of periods are based upon the planets. How it can be considered as our solar system only. How the planets are revolve around the sun. So it can be said as to be orbits, areas and periods. How it can be revolves. So Kepler. Before that, who is Kepler? Johannes Kepler. His full name is Johannes Kepler. Johannes Kepler. Actually, he is a physicist. He discovered the three laws according to the planetary motion. So the first law is laws of orbit. Laws of orbit. What it denotes the laws of orbit? Each planet moves around the sun in an elliptical orbit with the sun at one of the foci of the orbit as shown. So here elliptical orbit. So we draw the solar system, that is the sun, that is Mercury, and the other planets are revolves around the sun. Am I right? Yes. So the Kepler says the other planets are revolve around the sun in elliptical orbit. So what is elliptical orbit? Elliptical orbit. So elliptical orbit is nothing but the circulation of path. It covers a circle path is called elliptical orbit, and the Kepler say elliptical orbit is more than 0 and less than 1. So it can be clearly considered to be 0.5 to 0.8. So sorry, plus 0.1. 0.8 to 0.5 to 0.9 is considered to be elliptical orbit. So the decimal between 0 and 1 are considered to be elliptical orbit, and it covers a circular path is called elliptical orbit. So it says each planet moves around the sun in an elliptical orbit with the sun at one of the foci of the orbit. All planets are revolve around the only one big planet is called sun. So it revolves around in elliptical orbit as shown in the figure. I draw the figure. So this law is called Kepler's first law of planetary motion. So orbit, it denoted by orbit. How does the planets are revolve around the sun? In what orbit? So this is called the elliptical orbit. Elliptical orbit, he only discovered the planets are revolve around the sun in only in elliptical orbit. In second law of area. In this law of area, it denotes the line joining the sun and the planet sees out equal areas in equal interval of time. So we know well a earth revolves around the sun in 365 days of a day. 365 days and 8 hours, I think, for 8 hours. So the ratio will be constant, thing not can be changes. He said the laws of area, the line joining the sun and the planet fit out equal area in equal interval of time. So this is sun, the other planets are there. So the between the line passing through the planets are in equal area. This year also this is equal area. Next year also this is equal area. It cannot be changes. The same area, it cannot be changes. This is constant thing because They revolve around the sun in constant day and hours only, so it cannot be changed. And next is, this law is called Kepler's second law. So we say with an area, the area is not changeable, it is a constant thing. And next one is, it means aerial velocity. Then aerial velocity is equal to area traced by then by time. So how much aerial velocity, how to find aerial velocity between one planet to each planet means we need to know about area traced. So how much of area traced between one planet to another planet, so we put in this, and how much time it will be taken. The simplification of both, we get the area velocity. So this is second law of area. So the area will be the constant, not change in area. So you said in law of area. Next one is laws of periods. We see about laws of orbit, laws of area. Now we see about laws of periods. He said the square of the time taken by a planet to complete a revolution around the sun is directly proportional to cube of semi-major axis of the elliptical orbit. He says the square of time taken to a planet to complete a revolution around the sun. So square, we know about the square feet. Square feet is considered to be, so how much of square feet is considered to be between the sun and the earth? It's called number of square bits between sun and the earth. So you said square of the time taken by planet to complete a revolution around the sun. How much of the square bit to take to revolve around the sun is directly proportional. I say once again, how much of square feet to revolve around the sun of each planet is directly proportional to cube of semi-major axis. Square is equal to cube of semi-major axis. Square of revolution. So square of revolution equal to cube axis. It makes revolve around the sun in much of square, which means it can be equal to cube axis is directly proportional. So you say in laws of period. So that's all the video. Thank you.